So the subject of this panel is going to be on how do we practically build terawatt scale solar? How do we get the land? How do we get the labor? How do we change will to do that? Sound good? Excellent. So I'll let each of you guys maybe just give a really quick introduction, pithy as well, who you are, what you're working on, and we'll jump into. Oh, if you like to.
Hey everyone, I'm Alex. I'm working on Astro Energy. We're an early stage solar developer working in Texas right now. So we're looking to bring on, 100 megawatt scale solar facilities. And we're working on basically identifying the optimal locations for these sites, securing land options, working with permitting and interconnection, and trying to basically thread the needle in that process.
Everyone. I'm Banks Hunter. I'm the CEO of Charge Robotics. We build robots that build solar farms. So we're automating the construction of utility scale solar with advanced robotics. That's pretty much it.
I'm Chehrehsaz, CEO of TerraVerde Energy. I help my customers solve energy puzzles, primarily focused on public agencies in California that have high demands to help them build microgrids and get off the grid.
And today we're thinking about a lot of like the megawatt scale microgrids and how we scale that to macrogrids. So my first question to all of you guys is, we heard, as I mentioned before, 3 challenges come up. How do we get the labor? How do we get the land? How do we get the will and capital to build this scale of all of us doing solar? So I want to start with each of you guys. What do you view as the biggest challenge, or what do you view as the solution to get over any of those?
Yeah, so I think we need to work on like everything. I think there's a ton of challenges. But the interconnection queue obviously is the reason why we're talking about doing like off-grid solutions. So I think that is like a super inefficient process right now. As people talked about before, there's like a, like 90% failure rate in a lot of the projects that are trying to move forward there. So I think basically, well, there's a lot of things we can do on the regulatory side of things, but also I think basically there's solutions that can be built to try to tackle like the full scale of like, how are we connecting where land connects with power, connects with the substation, and basically build out like a scalable solution where we're finding where can we deploy megawatts at like cheapest dollar cost, and basically scale it out essentially.
Yeah, for sure. We directly solve labor problems. That's why we're working on it, is because we've identified that as the #1 scaling bottleneck for new solar. So actually, when I got started building Charge Robotics, I interviewed about a dozen of the largest solar construction companies in the US and asked them, what are your biggest scaling challenges? What's not working about your business? What do you need to change to continue scaling with the growth curve of solar? And every single one of them actually told me that they've been turning down projects because they literally don't have the workforce to build them. So as demand has continued to rise, tracking the prices falling for new solar build, the construction companies literally can't find the workforce to deploy thousands of people out to these remote desert locations to build massive solar farms by hand. And so I looked around at, the nature of that problem, looked at how solar farms are constructed, and that is why we are building robots to automate that construction process. So I think that is the #1 problem in the industry. And there's a big McKinsey survey that came out about a year ago that was like, they went and talked to every single person in the solar industry and just ranked the top scaling problems. And #1 is availability of labor. So, 100%.
Yeah. Oh, feels like. I'll speak to this from what's helping me help my customers to deploy microgrids. And it really has been the laziness on the status quo and the benefit of technology stack getting better that is getting us to this point. The laziness being the otherwise available option for securing power is the utility. And Giga recently put on his podcast, he said, innovation in utilities, innovation goes to dying utilities, right? Like they haven't actually innovated the grid since 100 years ago. And having been in business, serving my customers for the last 15 years in California, that problem statement has gotten so much worse. Reliability of power, cost of power, just the service level of it is at the lowest it's ever been. And in parallel, last 15 years, technology stack have gotten cheaper, better, and faster, right? I'm not saying job is done. Absolutely. Robots building stuff will happen, will get us there. But we used to have solar, then batteries, now different kinds of generators, now multiple battery technologies. So we get to a place where you put the Jeff Bezos lens on of like bet on things that aren't going to change. Like from 10 years ago, if you bet on the utilities will not improve, it will get worse. and technology will keep getting better. At some point, you'll arrive here today, which Louis very excited to hear this, Max. Today, I shipped a report to one of my customers, which is water agency in California, to help them build, and this is the title of my report, Max, you'll be proud of this, to help them build a macro grid.
I love it.
And this happened over an ideation that I had with them because they had so much pent up demand of like, we need to find a way to power our own infrastructure. I've been touting self-generation for self-consumption for years. Now it's actually landed. People are like, yes, I should be my own farmer of energy. I should create my own power. So the premise for this plan that I did today was building 3 microgrids that are separated. Phase 1. Phase 2, connect them all up by power lines, underground, broke AB lines. Phase 3, build out a transmission level substation. This is a water utility that has a statutory code that allows them to generate, transmit, and sell power. And they've had enough. They actually want to generate power and make their own microgrid, upon the macrogrid, to get that term out there, to serve themselves and their community in their county. And that's why I get so excited about finally the things that we've been betting on are actually here. And what's going to propel us, what was one of the hardest things to do 15 years ago, was convincing people this stuff would work. Now the equation has changed. The phone calls are coming in. Help us get off the grid.
So I'd love to maybe do a little bit of back of the envelope. And thanks for reviewing a little bit before this. So everyone else will put you guys on the spot. No worries. But if we say we want to get a terawatt scale grid, let's say it's more or less continuous, maybe it's not exactly, and for inference versus training runs, that could be different. But let's just say we want to push things to the extreme. We want to build a terawatt. My back of the envelope calculations is you're going to need about 20 million acres of land. That was the numbers I was showing you. That sounds crazy, but remember Arizona was like 75, so I'm talking about 3rd of Arizona. Okay, and that's what we're building on. If you guys were given an unlimited budget, say there's some debate because the data center market's really expensive. Like my back of the envelope and half of that is the order of tens of trillions of dollars, although that'll get cheaper over time. But if you were given an unlimited budget today and you said, okay, we want to go out there and acquire 20 million acres contiguous, how would you do that? How much capital, or how would you think about even how much you need to raise to do that? And on the robotics front, for the installation, I'm not sure where you guys are in your phase, but like, how many of these robots would you need? How far away are you from being able to actually ship how many bots it is to build that? And maybe we'll start with Vegas.
Yeah, for sure. I think it's a great question to think about. And it's also kind of crazy to look at the scale of what we're deploying right now. So if you look at what energy generation we're rolling out across the US right now, about 84% of it is already solar. So we are already the dominant energy generation technology by a mile. And we're building, in terms of utility scale, we're building something on the order of 40 to 50 gigawatts a year. So, I mean, the line to a terawatt is in sight. Like that is a realistic target. Right now, the low hundreds of our robots would get us there to actually rolling out the entire solar generation capacity of the.
And how many do you guys have now?
Wait, 1. Yeah, building our first 3 over the next quarter. And so in terms of land usage, I think I was telling this to Max, my favorite statistic on this is if you do the math on the amount of solar that it would take to power the current US energy grid, it's about 4 times the land area of golf courses. It's not infeasible. It is a lot of land, but it is a realistic target for, we want more energy. Where are we going to get that from? Solar is the cheapest way to get it. And that takes some land, but it is like you said, I think for a terawatt, it's order of a third of Arizona. We can find that across the US.
And while you still got the mic, can you explain to us the robots? How do the robots work? And why do you only need a couple hundred? That sounds low.
Yeah, for sure. These are basically high volume assembly lines for solar farms that operate on the field. Really quick summary. If you picture a shipping container with a modern assembly line in it. So like if you've seen a footage of a car assembly line where you have giant industrial robot arms picking up big pieces, moving them around. We're doing that with solar farms. So we're grabbing solar panels, we're assembling all of the mounting infrastructure, in this portable shipping container unit that is full of robot arms, sensors, conveyors, and automating that construction process. And for some reason, it's just very high throughput. So we're able to, with our system, install one solar panel every roughly 30 seconds. And that turns out that scales to, if you run it continuously, we're able to build solar farms pretty quick.
I'm happy to go next and just touch on the notion of land being a problem is such a made up issue. We gotta get past this. I've never had any of my customers that wanted to deploy solar or solar power microgrid have an issue about land. And we're talking about California, busy metropolitans, and along the coastal regions, let alone the Central Valley where there's ample land available and ample sun. The macrogrid concept that we're working on now, this customer has 400 acres of land that's just sitting there. They don't have to do anything with it. And there's no other use case for it. And it's right around the coast. They're fine. We actually use that as power generation. And they want to do that. Nobody's going to force them to say, use this land, take it away, eminent domain. It's actually what they want to do. So the land concept, I think, is very overblown. I hope we get past it as a society. South Korea, I think, just passed a law. I'm not sure we saw that they're forcing essentially every parking lot of over a certain square footage to have solar shade structures. It makes sense. It's just like sitting there. Like,
Yeah, right on.
it's like, what else are you going to do in that parking lot? Like, if you're not going to build more stories, put solar on it. So, yeah, I think land is going to be a non-issue very soon. And yeah, we get to build them at no cost and no land.
Yeah, I agree on a lot of those points. I think like definitely also like these off-grid solutions, you can just go out there and find land and kind of build your own grid. I guess just to touch a little bit on my experience as well, like I think it is a pretty challenging question as well as if I want to connect to like the utility scale system, you kind of need to scale up the systems to analyze like where is there capacity available across all of these substations. How am I kind of aggregating the nearby like land parcels and identifying like how can I aggregate these to build my solar farm? So I'm a big fan of like a scalable solution there to be able to analyze kind of all those different parameters. Because I think if we're going to reach like terawatt scale, I think it's going to be a combination of like off grid and like on grid connected. And like, even if we do build a lot of it off grid, we need to figure out how to connect to the right off takers and like make sure it makes sense economically.
So as a follow-up for you, Alex, how much of this is basically needing the right data modeling? And Alex is he's certainly one of the big brain traders here. It was a trading energy at Citadel before. So how much of it is you just need the quants to basically develop software to tell you what land to buy? And then how much of it is, always making it sound like it's relatively straightforward for a lot of people. And I buy that, like they want to go solar. But like, let's say you've got, I don't know, like you got huge parcels of land that are really excited, and you got other really valuable land where the people are being stubborn. How much of it is also you just need like good landmen that are going to go out there and negotiate?
It's a huge part of the problem, for sure. And I think like figuring out kind of the right strategy for approaching those, like, whether it's private landowners or whatever it may be, that's like a huge part of the problem. But that being said, I think also there's a very small number of projects that are being submitted that are actually like legitimately have a successful probability of like connecting to the grid. And so while I think there's a lot of friction on like the land aspect part of it, there's still a lot of wasted effort in doing that land effort on land that a substation is just not going to work, whether it's because there's not enough capacity there or because the pricing isn't attractive, or like many other reasons, essentially.
Yeah. Well, question to all of you guys. We're going to go deep on this tomorrow, as wherever you went and Casey. But what is y'all's view as people that are super deep in solar and storage on, well, I guess two-part question. One, how much of this terawatt scale grid really needs to be contiguous for either training runs or inference? That's number one. And then number two, how much do you believe that it's not perfectly contiguous, we need transmission and distribution at all? Where do you think if you just, once again, left side of the curve, back of the curve, solar storage gets so cheap, the vast majority of this just can be offered. Whoever wants to.
Yeah, I'm happy to jump in and maybe also like have a divergent thesis or at least expand it. I think the notion of how do you get to terawatt scale solar, which is this is the panel. It's easy to think about it as there's deserts available, go eminent domain, the whole thing with solar, right?
And that could be the answer.
That could be the answer, right? Where I come at it and spend my time, reputation, and effort is on distributed sides, right? Like I think we'll get to terawatt scale by just building on the land people own because they want the power. Like that's I work backwards on the customer's needs. In case of like the major data center needs, like the customer is the data center, they have to go build it somewhere and they gotta get the land. So a lot of problems there. I mean, you guys faces, that's how you're helping solve that problem. But ultimately you run into this is my property rights. Before doing distributed generation, I did a short stint in large scale utility scale development, like 3 gigawatt scale power plants back in 2009. And I saw firsthand how hard it is to actually go to every single landowner along your transmission line to get the rights and negotiate a deal so you can build mile after mile after mile of your project. And it can get done. It is very difficult. You butt up into property rights, humans, emotions. Now, if you got God amount of money like Google or others, like Elon Musk, you go figure it out. You spend enough money to get it done. But I don't want us to miss the point of build the power generation for those that want it, and they will come to you with the solved problem of land, space, and you connect it all up. As far as like how will it all get connected, I think we're not going to rely on utilities to help us get it connected. I think we're going to build our own transmission, distribution infrastructure, buried lines, running in parallel with the old grid. It might be like the interstate analogy, right? Like it used to be these highways, right? The interstates came in and those highways became abandoned. We might be getting down that path where the utility infrastructure built by investor-owned utilities is like the old Highway 66.
Yeah. It's good enough.
Yeah, I'm going to say I don't think that contiguousness matters that much. Like, I do think that you're looking for your economies of scale of like, okay, if you could put a gigawatt in one place, it's going to be a lot cheaper than putting a kilowatt on your rooftop, right? You're going to get great economies of scale, but those don't scale that much better past something in the, like once you're in utility scale, you're talking anything 10 megawatts and up, you don't get that much more efficiency from having additional contiguous co-located generation. So I think from a first principles perspective, transmission is shockingly good. Like the actual physics of transmission, you get something like 0.5%, maybe 1% loss per 100 miles of energy transmission, which means like it's actually okay to have distributed generation like way out, in the desert, 100 miles from you barely lose anything. I think the issues come from, okay, well now you need regulatory compliance, you need buy-in from all the landowners. There's a lot of kind of non-first principles issues that you start to run into when you're building a real energy grid. But from like a pure like physics perspective, transmissions will be good. Building at scale is good from a cost perspective, just taking advantage of your economies of scale. But it's not like we need one block of all of the solar to power, the entire grid in one place. In fact, I would argue that's actually bad from a reliability perspective and resilience, where like, okay, now you have some crazy weather events in your one section of generation and, like Texas-sized hailstorm knocks out a whole country or whatever. You get security and reliability out of spreading out your generation a bit.
Yeah, I agree with that point. And also to add on to it as well, when you start co-locating, you have like solar plus batteries, like the sun is moving, right? So, I mean, over time, I think it makes sense to kind of have this communication where it's sunny in one region. Okay, we're charging batteries over there and we're moving it over as the sun moves versus obviously just like distribute everything on like one plot of land. But it's balancing that with the economies of scale, I think. I definitely think as you get into like the hundreds of megawatts, you're kind of spread your costs more such that you have like, you spread your dollar per megawatt more essentially. But it's kind of balancing those two factors.
Yeah. So if we're doing some more sort of bottoms up analysis here, so we talked about land, we talked about the labor. Let's say you wanted to build a terawatt. So let's say solar storage and data centers. What about just like the raw materials? Like, do we have enough lithium? Do we have enough silicon? And if, by the way, something else we're going to talk more about is in the breakouts, if most of this is happening in China, to use a French term, how fucked are we if all of a sudden they turn this off tomorrow? How long would it take for us to get to the scale we could do manufacturing of terawatt worth of battery and solar here in the US?
Yeah, I have a lot of takes on this topic, but a few like core building blocks to look at here. So one is that in the US currently, about half of solar is produced domestically. So there's one supplier for solar that is kind of the domestic supplier. They produce about half of the market. Um, Everything else is sourced globally. And the inputs to solar are highly available, right? You need aluminum, glass, and silicon. And those are some of the cheapest, most abundant materials that we have access to. So then you need energy to process those and convert those into solar panels. But there's a reason that solar is really cheap. And it is because it doesn't rely on things that are hard to find on Earth, which is great. So I think there's kind of the separate like first principles answer from the like geopolitical reality answer, which is from a first principles perspective, it's really easy to find inputs to make a shitload of solar.
Batteries too?
Batteries are getting there. Yeah, I would say we've seen the price of batteries decrease massively over the last decade. I'm sure you've seen. I think the statistic I gave you actually was something like 7 years ago. We had about 5% of utility scale solar sites had co-located battery storage, and that's up to 95% plus today as costs have driven down on batteries. So I don't know what the like makeup of lithium sourcing is globally. So I would have to look up from like a sourcing perspective. Yeah, to see what the impact would be there. But in terms of actually building solar panels, like those come half in the US today, half globally, but the materials are easy to find. It's great.
I have nothing else to add beyond headline news. You found another lithium mine somewhere, and
Beautiful. So another question I have is, let's say, I know we've been very kind of like let it free markets high end here, but we did talk about grandmother solar panel, and I do think it's really important to keep in mind, like, how does this fit within the broader world? One question I know Casey's written about a bit is like, what happens in, let's say fusion does work, and that's like an incredible solution. And we just basically taken over the vast majority of the world's planet. Turns out the AI paperclip maximizer was in fact a solar panel maximizer. And all of a sudden now I feel like we don't really need any of this. What is your view on how that recycling process can work? Is that should be solved by technology itself? Is that kind of thing that we as a society should be an insurance fund together for? How do you think about that sort of long-term transition?
I'm happy to tell you my real world experience. Like, this is happening in my business right now. We are currently going through recycling, retrofitting solar projects that we did starting from 15 years ago. And there's very healthy available supply chain of removing old solar panels, putting new ones in, replacing old inverters that were 480 volt, diving into 1000 volt, putting new ones in. Same thing with batteries, like early generation recharge network batteries. My friends who know, they're all bricked out, all getting removed. There are companies now with thousands of employees that are going around removing old stuff, recycling them, reusing them. The second generation use case of batteries is pretty exciting. I got hit up over the weekend from a friend that joined a reuse battery company startup that competes with Redwood Materials. He's quoting me $120 per kilowatt hour batteries on small scale that you can deploy. And that's fully ITC eligible, domestic supply, can source from here. So you get 50% ITC, plus $60 per kilowatt hour. I can now get a commercial sized battery deployed. And this is still, for me, it's year 15 of doing this. Like, we are solar lead. Like, this is like, that is so cheap to recycle and reuse, replacing them all is going to happen. And yeah, there might be a world where like fusion, fission, all that kind of stuff kicks in. But for the next decade or so, what I know is this: once you go solar, you don't go back. I have had nobody come to me and say, you know what, the solar project that we just did, let's get rid of it. I want to go back to the grid. Said no one ever.
Bring the coal back. Come on.
Yeah, for sure. Recommissioning is a real thing, but solar panels last a pretty long time. So typically their warranty 25 to 30 years out. They're still producing 80% of their original nameplate capacity at that time. The reasons to recommission projects are you want to reclaim the land, you want to recycle those panels. All the materials are pretty easily recyclable, but I think my big picture perspective here is it's hard to imagine a world where we want less energy in the future. I don't think we're ever headed there. I think fusion's great. I don't think there's any world where fusion is free. And so we'll kind of see in the long term where those cost curves line up once fusion exists. So we'll start there,
Yeah.
and then see how much it costs. But I think right now we're in the world where solar is the cheapest way of making power, and we want more power and should build it.
Yeah, beautiful. One question, I guess, for you, Banks, we talked about with Shrev. He made this point that on paper, if you want to build these giant solar and storage data centers, it makes sense. But then when you get in there, there's all these little things, how this wire doesn't connect and the standards and like there. You're automating these solar piece, which is awesome. What is your view on this? What I was asking them beforehand. Can you build this robots to automate the construction of data centers? Or can you?
Yeah, this is something that we don't do. So I only have a surface level opinion on, but I do think like some of what Presidio is doing with like portable compute units. I think there is a real future where we're building modular pieces of data centers and then just slotting those together on site. So like prefabbing, a kind of the same approach to prefab homes, but prefabbing sections of data center where you have integrated wiring, you have your compute cluster, and you just take those building blocks and stack them together out on site. I think that's a world that makes sense to me.
Sounds like a company worth exploring. I know Crusoe's already there, but there's probably a lot of you. So I'm going to ask 2 wrap-up questions. I think we'll have time for a few questions in the audience. Get those going in your head. Do you have them? My wrap-up questions for you. Number 1, if you could wave a magic wand and change one thing that makes this, whether it's policy, technology, whatever, much more possible or much easier to get to Terawatt scale, what would it
Get rid of tariffs.
be? You missed the warning, but it was all free markets.
Yeah, free markets. Yeah, get rid of a lot of the regulations.
Yeah, mine is, I think I talked about it in your podcast. Get rid of incentives. Like, stop trying to promote something when you're already way past the point of needing it. If I could have my choice, I would say incentive-free, permissionless distributed power is will get us there.
Amen. Another final question for you guys. Sort of thinking very big picture. Let's say solar plus storage gets below 2 cents a kilowatt hour. Let's say it's below 1 cent a kilowatt hour. We start approaching free energy, asymptotically free. What does that do to the world? Like, what's the coolest shit that you can imagine that basically free energy is going to do to change all that?
Oh, that's a question.
None of us will have to work. Yeah, we'll have a bunch of intelligence explosion of people and robots doing things that we want. We'll be able to pursue kind of whatever we want to pursue, our creative, endeavors, or the people who love building will probably still be trying to build and use these tools to help them. But yeah, it's a beautiful future.
Yeah, I think a lot of things start kind of breaking. Like water shortages stop becoming a thing. Desalination becomes free. Manufacturing basically becomes free. Like the cost of building anything is really the energy required to refine and process the materials involved. So like manufacturing becomes free. Food production, the costs there are really the energy inputs that are required. And so food becomes free and abundant. I think a lot of things really just fundamentally break once we hit that point, which is, and they all break in pretty exciting ways, I hope. So,
Hey, how far out do you think this is?
oh man. Yeah. If you're gonna take me to I think you threw out 1 cent a kilowatt hour for solar plus storage. I think like high confidence within the next couple decades. We're looking at that. Moderate confidence in the next decade.
Let's go.
Yeah, I think speaking of things breaking and maybe more pessimistic view, a lot of utilities will have to take a bath on their investments and rethink their business models.
Also true.
Yeah, that will need to happen. But yeah, I mean, abundance comes from energy as its foundation layer. I mean, you mentioned desal as one of the largest drivers of electricity growth in California and a lot of other places. Farming, replenishing the ground source water, right? Powering any building, whether it's data centers or humans. That's where it's gonna all come down to.
I will add, although I love this beautiful vision, I share this with all of you guys. I think we're also going to hopefully need some evolution of human nature as well to make the most of this, right? So I think that's a separate question, perhaps even above our pay grades for today, but I think it's awesome.
Better money.
Huh?
And a better money.
Well, I mean, well, there is a panel coming up. All the big players were once again, right? So we'll hear about that again. Any other? Oh yeah, questions from the audience. Yeah, I guess time for a couple. Yeah, and I don't know if we want to do.
Just yell.
Yeah, just yell.
How useful is hydrovoltaics? Is that anywhere you go?
I'll share with you the opinion I share on Twitter. I think it's one of those marketing wash things. You don't need to clean wash like, oh, this land is agrivoltaic land. I'm sure it's good. There's value to it if it needs to happen. Right? That's where you're building your solar. But we don't need it in order to go build solar. Just ample land available.
Yep, pretty much. I think like in some areas that are land constraints, it's useful. But if you don't have a land constraint, that will get you a lot.
Sweet. Other questions? Yeah, feel free to stay out and shout.
I think one thing that you guys didn't touch on in your video about is people will be able to live anywhere. So we have jurisdictional arbitrage. So you can live on a flag on the middle of the ocean, live in the desert, go wherever you want, find a government that you like.
So the sovereign individual becomes a reality. Yeah, that's certainly one possible. I don't know if add to that. Any other questions? Yep.
Elias, looking you could expand on like the usage profile of the water utilities and why like solar and storage makes sense for them. And kind of reconcile a lot of what Scott was talking about this morning about like the land constraints of power data center, like in terms of like size of project, it's some true profile, like how do they differ? How do you get data centers water on like solar and storage mindset rather than on site gas?
Yeah, sounds good. So this question will reveal a lot about me. Max started by calling us all solar maxis, and I've mentioned this to him. This is where my focus is. I don't hate on other generation technologies. I also love Bitcoin. I don't hate on other crypto, but Bitcoin is what I do. And I don't hate on utility scale solar. I do distributed. So I share that because, powering water infrastructure like desalination plants using reverse osmosis is essentially pumping water through membranes is just like powering a data center. So a very like reasonable size desal plant that runs 5 MGD, 5 million gallons per day of water. It's not a lot, doesn't take that much footprint. One of those plants, real life application here in Monterey, California, more than double the total electricity usage of that whole water agency, right? More than double. A 5 MGD desal plant required about 13 gigawatt hours of electricity per year on an annual basis. And these things run mostly flat, right? They're kind of like data centers that don't like to flex as well. So powering them is not going to happen today with solar that has a 25% capacity factor. And batteries are largely designed for the California 4-hour market peak shaving, right? Once the market shifts a bit more, maybe like 8-hour batteries will make more sense. But right now, batteries are focused on 4 hours. That's where the economy of scale lie. So to actually power these things up under the theme of self-generation or self-consumption, we're using hybrid renewables. And the ratios are somewhere around, you have 3 megawatts of solar, 8 megawatt hours of batteries, and you have 500 kW of nat gas or linear generator, which are cool technology right now. I love it. It has all air quality permits in California. You plug in natural gas to it. With the gas price arbitrage in the state, you can actually produce electricity with natural gas coming from the pipeline at 12 cents a kilowatt hour. That is way cheaper than the electricity coming from the grid itself.
Yeah.
Why in the world would you use batteries to power desalination plant with solar water instead?
If you have a tank and you want to use it, you can possibly do that. But a lot of these projects just get built. And that's kind of the thing we have to understand. These water infrastructure, they get built by water engineers. They're not power people. And they go about and deploy these multi-billion-dollar desal plants the way they do them. And they assume there's a grid to connect to. They still have not woken up to the reality of, oh, maybe you should have a water reservoir and use that as your battery bank, or get smart about energy optimization.
Maybe one last one. Yeah.
Yeah. Question for you guys, when anyone else wants to take it. Are you looking at storage ever in your projects? If not, why?
Definitely. Yeah. I think you mentioned a quote on how much that's grown. Yeah, it's taking over, especially like in ERCOT. It's been, we mentioned it a few times, I think today as well, how it's reduced a lot of the volatility in the market. And we've kind of seen that the last couple of years in ERCOT. So yeah, it's definitely a good thing to co-locate, especially with solar. So.
All right, guys, let's get a round of applause. Never like commercial.